Assalamu alaikum. I hope everybody is doing great. As you all know, that we have already started at chapter number 1, which is quadratic equation. And in this video, we are going to finish this chapter. The exercise that we are about to finish is exercise 1.4, in which we were solving radical equation. Let's see which type of radical equation is given in this video. We are going to solve radical equations of type 3. And what is type 3? Here we are having two radical signs. You see x square plus px and x square plus px. So we are going to make some substitution so that we can solve this radical equation. Right, so in this let's solve question number 9 of exercise 1.4. Here we have x square plus x and x square plus x. The two terms are same, so we can easily do the substitutions. So we can write that y is equal to x square plus x. So our equation 1 will become square root of, instead of x square plus x, we'll write y plus 1, and minus, instead of again x square plus x, we'll write y minus 1, which equals 1. So our equation has become more simpler. So now we are going to remove the radical signs by squaring both sides. So y plus 1 square root of y plus 1 minus square root of y minus 1 whole square, and on the right hand side we'll also take the square. So you see here on the left hand side we are having a minus b whole square, the second algebraic identity. So we'll open the second algebraic identity, which is the square of first term, then minus 2ab, and then we have plus b square, the square of second term, and on the right hand side square of 1 is again 1. Right, now we are going to simplify the left hand side. Square will get cancelled by the root, and from the first term we are left with y plus 1, and from the last term we are left with y minus 1. And under radical sign we are going to solve both terms. We are going to multiply them, y square, and if you see clearly, then we are having the third algebraic identity, and we can directly write as will get cancelled by square minus 1, right? So if you remember the third algebraic identity, you can come directly to this step, or if you don't remember it, you just can multiply the two terms, right? So what we are going to do next, we'll take this term to the right hand side of the equation. Okay, now our type 3 is converted into type 1, where we have just one radical sign. So what we are going to do, we are going to remove this radical sign by squaring both sides of the equation. So minus 2 square root of y minus 1 whole square, and 1 minus 2y whole square. So square is on minus sign, it will get plus. Square is on 2, it will become 4, and here we are having this. And on the right hand side, this is again the second algebraic identity. We are going to open it, and on the left hand side we'll open up the square, and we'll move all the terms from the right to the left side. If you see, we have 4y square minus 4y square, and we are having 4y minus 5 equals 0. This implies y is equal to 5 by 4. So if you see, our equation was in x and we made substitution, the equation then became in y. We found out the value of y. So again we have to resubstitute its value. We insert y instead of x square plus x. So we'll do the back substitution. We remove 4 from here. We multiply the whole equation by 4 so that we can make it in the standard form. So now you have to solve the equation for x. If you see, we cannot break the middle term, so we'll apply the quadratic formula. Here a is equal to 4, b is equal to 4, and c is equal to minus 5. I hope you remember the quadratic formula. For you, I'm going to write it down again so you can easily insert the values of a, b, and c in the formula. Here we have minus 4 plus minus 4 square minus 4ac divided by 2a. So minus 4 times 16, and we have 4 5 times 20. 20 into 4 becomes 80 divided by 8. So x equals minus 4 plus minus 96 divided by 8. So if you further simplify it, you can easily write it as x equals plus minus 4. Square root of 96 can be written as square root of 4. 4 square root 6 divided by 8. So you can take 4 as common. So you are left with this, and then you can cancel 4 by 2. So you are left with x equals to minus 1 plus minus square root of 6 divided by 2. So this is the solution set. So we found out the values of x, which is the solution of question number 9. I hope you understand the steps of working. Let's solve one more equation, a radical equation of type 3. Let's see which type of substitution we are going to do here. Here you see we are having x square plus 3x, x square plus 3x. So instead of this x square plus 3x, we can write, let's say we are going to make some substitution. Let y is equal to x square plus 3x. So our equation 1 will become instead of x square plus 3x, we'll write y plus 8, and then again y plus 2 equals 3. Now we are going to do the squaring on both sides so that we can easily remove the radical signs. So we are having 5 plus 8 and y plus 2 whole square equals 3 whole square, because we are going to take square on both sides. So here we are having a plus b whole square. So we are going to open up the bracket by applying the first algebraic identity. So a square plus 2ab plus b square, and on the right hand side we are having 9. Let's open up the brackets now. Square will get cancelled by the root, y plus 8, and from the last term y plus 2. And you are going to multiply the two terms. We are having y square plus 2y plus 8y and plus 16. And on the right hand side we'll write 9 as it is. Y plus y becomes 2y, 8 plus 2 becomes 10. And under radical sign we are having y square plus 10y plus 16 equals 9. So we'll move these two terms to the right hand side, and we are left with here y square plus 10y plus 16. Here we are having 9 minus 2y minus 10. So you are having y square plus 10y plus 16, and we are left with minus 2y plus 16. And you can take minus sign common if you want it to be further simplified. Let's solve it further. We are again going to remove the radical sign, so we'll square both of the sides. So let's square both of the sides of the equation, whole square, and here we are having this whole square. So square is on 2, it will become 4. 4 square is on radical sign, it will get cancelled. Now here square is on minus sign, it will become plus. Square is on this whole bracket. We are going to open it as a plus b whole square. So a square plus 2ab plus b square. So on the left hand side we are going to open up the bracket. 40, 16 4 times is 64, and let's move all the terms to the left hand side. Minus 4y square minus 4y minus 1 equals 0. Here 4y square will get cancelled by minus 4y square. 40y minus 4y becomes 36y, and plus 64 minus 1 becomes plus 63 equals 0. Here we are going to have minus 63 by 36. Okay, 9 7 times is 63, 9 4 times is 36. So y equal to minus 7. So we are going to do the back substitution. We inserted y instead of x square plus 3x. That was equal to minus 7 by 4. So now we are going to convert the equation to to the standard quadratic form. So we'll multiply whole equation by 4. So having 4x square, 4 3 times 12x and minus 7. So we'll have 4x square plus 12x plus 7 equals 0. So since we are unable to break the middle term, so we'll apply the quadratic formula. Here a equal to 4, b equal to 12, c equal to 7. So let's insert the values in quadratic formula. We are having minus b plus minus under the root b square minus 4ac divided by 2a. So x is equal to minus 12 plus minus 12 square minus 4a and c, and divide by 2 into 4. Let's open up the squares and solve it. 144 minus 112 divided by 8. And here it becomes minus 12 plus minus 32 divided by 8. We can write 32 as like 4 square root 2 divided by 8. We can take 4 as a common factor. So here it will become 4 minus 3 plus 2 divided by 8. So we can cancel it. So we are going to have minus 3 plus minus under root 2 divided by 2. So at the end we just have to write down the solution set. Write down the solution set here. Solution set is going to be minus 3 plus minus under root 2 divided by 2. Hope you understand each step of working. Let's solve one more radical equation of type 3. Here we are going to make x square plus 3x and x square plus 3x as y. So let's make this substitution so our equation becomes more simpler, that y is equal to x square plus 3x. So our equation 1 will become radical sign square root of y plus 9 plus square root of y plus 4 equals 5. So we are going to remove the radical sign by squaring both of the sides. So square root of y plus 9 plus square root of y plus 4 whole square equals 5 whole square. So this is actually the first algebraic identity. We are having y plus 9 whole square plus 2 y plus 9, and then 2ab wali term we are going to write, and then the last square of last term, this square root of y plus 4 whole square. And on the right hand side we are having 5 times is 25. And now we'll open up the squares. Square will get cancelled by the root in the first term, y plus 9 will get, square will get cancelled by the root in the last term, y plus 4 will get, and we are going to multiply what is beneath the radical sign. And here we are having 25. Y plus y become 2y, 9 plus 4 becomes 13, and we are going to multiply the two terms. We'll get y square plus 9y plus 4y and plus 36, and here we are having 25. So we'll move these two terms to the right hand side, and we are left with y square plus 13y plus 36, and here we having 25 minus 13 and minus 2y. Let's further simplify it. We are having 36, 25 minus 13 becomes 12 and minus 2y. And if you see, we can take this 2 to the other side, and before that we just take 2 as common factor from this side. 2 6 times 12, and we are having 2. 2 will get cancelled on both sides, so we are left with this term y square plus 13y plus 36 and 6 minus y. So we have converted our third type of radical equations to type 1. So we'll further take the square on both sides so that we can get rid of this radical sign. Squaring both sides, so we'll get whole square 6 minus y whole square. So the radical will get cancelled by its square. So we are left with y square plus 13y plus 36. And on the right hand side, this is the second algebraic identity. We'll open it, minus 12y plus y square. If you see, y square is on both sides, so it will get cancelled. 36 on both sides will get cancelled. And we are having 13y plus 12y equals 0, which comes out to 25y equals 0, and we are having y equal to 0. We inserted y instead of x square plus 3x equals 0, right? So we have done the back substitution. So let's solve it now for the value of x. We can take x as common. X plus 3 equals 0. So either x equals 0 or x plus 3 equals 0. So here you are having one time x equal to 3, another time x equal to minus 3. So at the end you write down the solution set, which is going to be 0 minus 3 bracket close. So this is how we are supposed to solve the radical equations. We have done all types, right from type 1, type 2 and type 3. I hope you understand each step of working, and if you don't, you can ask me in comments. Thank you so very much. Allah Hafiz.